Chapter 6, Exclusive OR and Exclusive NOR Gates. The exclusive OR gate is a high output if one input or the other is high, but not both. The logic symbol and truth table are shown next. This is the logic symbol for exclusive OR. This plus sign with a circle around it. And this is the pin diagram with your two inputs A and B and your X. The truth table for exclusive OR can be compared with the OR gate truth table. You can see the OR gate truth table lets 3 of the 4 values through as 1, yet the exclusive OR only lets 2. This is because the exclusive OR only allows a 1 to go through when one or the other A or B is 1, not both or not none. The exclusive NOR is a complement of the exclusive OR gate. This is shown here. The symbols and the chip is slightly different. The symbol is the same as the exclusive OR with a plus sign and the circle around it, but it's negative, so it has this bubble as well on the chip diagram. And you can take the truth table of the exclusive NOR and compare it with the exclusive OR. This is just the reverse of the exclusive OR, allowing both values with 0, 0 or 1, 1 to allow through as a 1 for an output. Another thing to take into consideration is the parity generator or the parity checker. This takes electrical noise in the transmission of binary information that can cause errors. Parity can detect these types of errors. The parity system is either odd or even, and it adds a bit to binary information. It's an error indicating output, even in odd parity generators. As shown here, you have your 4-bit going through a parity generator, checking its parity as a 1 parity bit, jumps into the parity checker, and it checks the value to be correct and seeing if there's any error indicated on it from the transmitting device to the receiving device. This is another example where it takes the value 0, 1, 0, 1, and through your gates you get output as a 1 and a 1, and the parity bit is a 1, an odd for that. The number of 1s in the input plus the parity is odd. This is the chip diagram for the same parity. With an even and odd, you have your sigma E and sigma O as your summing outputs. Some system design applications here with your 8-bit digital computer going through a parity checker and your parity generator, checking it before it goes to the digital receiver point. And again here with your A-bit string and your B 4-bit string being checked against each of the bits to make sure A is not equal to B, or if it is equal to B, a warning buzzer will sound. And this is another example with an 8-bit input controlling with a control signal, checking to see if C equals 1 or C equals 0, dependent whether the X 0 through 7 equals the D's or doesn't equal the D's, equals the opposite of those D's. So in summary, the exclusive OR gate outputs a high if one of the other inputs but not both is high. The exclusive NOR, on the other hand, outputs a high if both inputs are high or both inputs are low. A parity bit is commonly used for error detection during the transmission of digital signals. Exclusive OR and NOR gates are used in applications such as parity checking, binary comparison, and controlled complementing circuits.